Alright, so today we're going to be doing 4 notes, which are on radical function. So, radical functions are basically the inverse of a quadratic function. But do you remember what happens when you take the inverse of a quadratic? It splits into 2. And we're looking at one piece of that. So one of the 2 pieces. Because we know if you put the 2 pieces together, they're not a function anymore, right? Because they don't pass the vertical line test. So this is what a square root function looks like. Now before you look at all of this, I want you to know that the parent function for a square root function looks like this. This is what we call its parent function, okay? That's just the most basic square root function there is. And just like every other type of function, it does have a standard form, or in some cases a vertex form. And these are denoted by the letters here. A is its stretch and compression factor. And if your A value is negative, it also means that we're reflected over the x-axis, okay? So this can also determine a reflection, and this is a reflection over, if you want to add this, over the x-axis, okay? Because there are 2 different types of reflections, so I do recommend adding that in. And then this is your horizontal shift. It's always the opposite. And this is your vertical shift, which is always just as it is displayed. So if it's up +4, it's up 4. If it's -4, it's down 4. It's just as it is displayed. So your negative A basically is a reflection across, it says y equals k, which is basically a x-axis reflection, okay? So let's go ahead and get into the rest of the examples. So number 1 says we have a, oops, I clicked on the wrong thing. I don't know what happened. Okay, so for number 1, we're looking at this radical function basically, okay? And it is the square root of -x plus 1 minus 2. So the first thing you're going to do when you look at one of these is you're going to determine if the x is negative or positive. Is the x negative or positive? Negative. If your x is negative, you need to factor out a -1 to make it positive inside the square root. So I'm going to factor out a -1. And in doing so, that's going to make my x positive inside the square root. So I just factored out a -1 inside the square root. If you wanted to get it back to its original form, you would just distribute it back in, right? Everybody good with what we did here? Now, anytime you factor out a -1, like this, you have a negative sign right here. What this means is that we have a reflection over the y-axis. Okay, that's what that means. So we're going to show how that looks in a bit. But before we do any of that, we're going to deal with a few other things. So the first thing we want to find is our vertex. So in order to find your vertex, if you have a negative x, you first need to factor out the -1, which we did. Once you've done that, you can now identify the vertex. So if it's a -1, your x is going to be a +1. And your k is always just as it seems, so it's going to be a -2. So that comes from here and here. That's my vertex. Now, your domain is basically all of the possible x values your function can ever take on. Now, most functions have an unrestricted domain, but a square root function does have a restriction, right? Because what can't you have under a square root for real numbers? What kind of numbers? Well, yeah, you can't have negative numbers, right? So what's the smallest number there is before we get to the negatives? 0. So we need to set your what's underneath your square root equal to 0. Okay, you're always going to set what is under your square root equal to 0. You guys see that? I took what's under the square root, I set it equal to 0. You can do this version or this version, you're going to get the same answer either way. So to solve for x, I add x to both sides, right? And I get, oops. Oh my gosh, what is going on today? And I get x is equal to 1. right? Everybody see how I got x equals 1 there? So that's the value that makes my square root 0. And 0 is okay in a square root, right? You can take the square root of 0. However, all the numbers that are smaller than 0 are going to be a problem, right? So let's determine what's going to make this undefined or negative. So 1's okay because it makes it 0 under the square root. Now, either you're going to look at values of greater than or smaller than 1. So pick a value that's smaller than 1. 0, right? So what happens if I plug in 0 here? Negative 0 plus 1. What's that? 1. Square root of 1 is 1. You can do that, right? So 0 is okay. But if we take a value bigger than 1, pick a value bigger than 1 to plug in for x. 2. This makes the 2 negative because the negative sign in the front. Negative 2 plus 1 is negative 1. Can you take the square root of negative 1? No. So our value is less than 1 or greater than 1, okay? Which one? Less than. Good. So your domain is actually from negative infinity to positive 1, also known as x is less than or equal to 1. So that's how you determine it. You set what's under your square root equal to 0, and you pick values above and below that number. So we're at 1, we can pick 0 and 2. When you plug it in, which one gives you a square root under the negative? That's the one you want to reject. The one that gives you a positive number is the way you want to go with your domain. Does that make sense to you guys? Now the range can be a little tricky. So if you get stuck on the range, you can always use your graph to help you as well, because you are going to have Desmos on your tests and whatnot this year. So how do you find your range? Well, you plug in your domain value, the value that's not the infinity. So what we're going to do is we're going to plug in that domain value into my function, so f of 1. So I'm basically just plugging in 1 for all my x's in my equation. What's negative 1 plus 1? What's 0 minus 2? Negative 2. So that's where my range is going to have its starting point, at negative 2. You plug in whatever your domain value is to get that. Now in this case, we have to determine if my range values are going up or down. Okay? So on my domain here, we have 0, right? Would be the next value on my domain, because 2 is not included on my domain. I can't plug 2 in for x, but I can plug in 0, right? So what happens if I plug in 0 into my function? I get negative 0 plus 1 minus 2. That gives me, what's the square root of 1? 1 minus 2? Negative 1. So are they getting bigger or smaller as we go on? Well, they're actually getting negative. If we go from negative 2 to negative 1, we're actually getting bigger, right? So it's actually, my range is from negative 2 to positive infinity. Negative 2 to positive infinity. And I'll show you another alternate way to figure this out too, as well. So now we're going to find our root. My computer is just really slow right now. Sorry. So now to find our root, we're going to set f of x equal to 0, okay? So you're going to replace f of x with 0. And that's going to give me square root of negative x plus 1 minus 2. So you're just replacing your f of x with 0. And when you do that, you're now just going to solve for x. So to do that, I'm going to add 2 to both sides. And that's going to give me 2 is equal to square root of negative x plus 1. Now, how do we get rid of a square root in math? Square it, right? Square both sides. That gives me 4 equals negative x plus 1. So I just subtract 1 on both sides, which gives me 3 equals negative x, which means x equals negative 3, right? So my root is negative 3 comma 0. So that's how you find it. You set your f of x equal to 0. So now, from here, you're now going to graph this thing. So your vertex is basically the start of your graph. Now, it's a vertex in the sense that it comes from a quadratic, but it's not going to be the vertex in the same way you guys are used to it. It's just the starting point of the graph. So we're going to plot our vertex, which is at 1, -2. It's right here. Everybody see how I got that vertex? And now we're going to plot our root, which is at -3, 0 right here. I'm going to plot both those. And your vertex is the starting point of your graph, and your graph is going to go away from the vertex like this. So it's going to be like this curve shape, and that shape is going to look like a quadratic as if it were on its side, okay? So for example, this is not part of the graph. I'm just going to give you a disclaimer, but I just want to show you. So pretend this is your axis of symmetry, okay? And this over here was the rest of your quadratic. You guys see how it's like half of the quadratic on its side? So that's what that represents. So now we're going to deal with our end behavior. Now, when we do our end behavior, just remember this is not actually part of the graph here. I was just trying to show you something. So the end behavior is all determined on the real graph itself. So, as my x value goes to -infinity, what is my function doing? Is my function going up to the left or down? Up. It's going up, but it's just going up very slowly, okay? So it's going to +infinity. And on the other side, the right, does my graph x ever go to +infinity? No. What's the biggest x value this function ever takes on? 1. And in that case, as my x goes to 1, what happens to my y? What does my y go to? -2. So when you do your end behavior for these, one of them is always going to be an infinity situation, and the other one's always going to be your vertex. See how it's my vertex just right here? You guys see that? One of them is always going to be your vertex. Now, say you were confused about the whole domain and range situation earlier, because I was confusing you, it didn't make sense how I was finding all those numbers. If that confuses you, you can always graph it first. You can find the root, you can find the vertex, graph it. Once you graph it, it's a lot easier to see the domain and range, right? Domain are all the possible x values. My function goes from -1 to -infinity over here. That's how you get your domain. My range is from -2 to +infinity. It's going up. So you can always look at your graph to determine those things if it's easier for you. And I would say it is easier. I just wanted to show you both ways. So now we're going to look at increase and decrease intervals. So remember, increase, decrease is always from left to right, okay? So if we're reading our graph from left to right, does this graph ever go up from left to right if you read it from left to right? No, it never increases, okay? When you do increase, decrease, you're always reading it from left to right. Now, when you're doing these square root or radical functions, one of these is always going to be never. Okay, one will be the case and one will be never. And then it decreases all the way from whatever your domain is, from -infinity to +1. And you never use square brackets on an increase-decrease interval, and you always use x. So it's always going to be your domain. And lastly, arguably the most important part of this lesson that I will expect you to understand is the transformation itself. What happened to the graph? So how we can figure this out is, I always like to look at Desmos just to kind of show you guys what's happening to the graph, but I'll show you how to figure it out, without Desmos, just using your brain and, the math itself. So this is my graph. So my original parent function is in red, and the blue is a transformation of that graph. So this graph has been shifted a few times, really. It's been shifted 1 unit to the right, and it's been shifted 2 units down. You guys see that? But not only that, it's also been reflected over which axis here? The y-axis. Very good. So transformation is 1 unit right, and that comes from this right here, because it's always the opposite. You always have to factor it up first. It's shifted 2 units down. That comes from this right here. And this -1 on the outside means that we reflected over y-axis. So those are the three important transformations that occurred on this graph. So how was that so far? Does it make sense, everything we talked about? Okay, let's try another one. So the next one we're going to look at is example 2, which says opens up and to the right. So the first thing we look at with this equation right here is, does this graph right here, or this equation, does it have a negative x? No. So if it doesn't have a negative x, it's not reflected over the y-axis. We don't have to worry about anything. We're ready to identify our vertex. So our vertex is always going to be the opposite sign here for your x, so -1, comma, 1. So if you don't have to factor out a negative x, you don't have to worry about that. Your vertex is more obvious. Now, I'm going to try graphing it before we identify the domain and range this time, so that you guys can get a better idea of what I mean by that. So to find your root, you're going to replace your f of x with 0. And you're going to solve. So to solve, I get x by itself, I subtract 1 on both sides. Now when I get to this stage where I subtract 1 on both sides, I think I have a problem here. If we look at this step here, is it possible to take the square root of something and get a negative answer? No, it would be like negative, something with an I in it. But this is not possible, is it? It's not possible to solve. So does this have a root? Yeah, it's not possible. So if it doesn't have a root, it means it never crosses which axis? Never crosses the x-axis. And that's okay. It doesn't have to cross the x-axis. It just means it never crosses it because the solution isn't possible. It's just not. It's an impossible solution. So now that we figured all that out, we have our vertex, which is at -1, 1, which is like right here. You guys see that? And that's cool and all, but we're gonna need some more points to figure out where this is going, right? We know it's opening up this way, but we kind of want to know where. So in the case that this happens where you only have 1 point, you have a few options. You can just plug in points to see what happens. So what if I plug in 0 for x to see where that goes? We just plug it in. That gives me 1 plus 1, which is 2, right? So 0, 2 is part of the graph. And you could also plug in 3, because 3 would work out well. 3 plus 1 is 4, square root of 4 is 2. It would be 3, 3, right here. So you guys starting to see how the graph looks. You can always just make a table and graph. And I will just mention, okay, as a math teacher, anytime that you want to figure out what the graph of something looks like, you can always make a table. I can't tell you how many times I've been on a test or had to do a test of any kind, and I didn't know how the graph looked. I didn't remember its properties of its parent function. I literally just made a table where I picked x values so I can graph it, and then once you get there, you can kind of get your bearings of what the graph looks like. So you can always just make a table if you get stuck. I just want to make sure you understand that. So this is what your graph's going to look like. Okay, I basically just picked a few points to find out where it was going. Your vertex is always the starting point of the graph because it's basically quadratic tipped on its side. So now that we've done all that, let's find our domain. So my domain looks like it's going from -1 to positive infinity. You guys see that? It's going this way. And my range looks like it's going from 1 to positive infinity. Now I want to show you something. If you look over here, what do you notice about the vertex and the domain and range? We used the x and the y in the range. You guys see that? What about this one? Did we do the same thing over here? The x vertex coordinate is in the domain and the y vertex coordinate is in the range. That's always going to happen. So another thing to look out for. So now that we've identified all that, let's look at our end behavior. So as my x values go to, does my x ever go to negative infinity? No. Does it ever approach negative infinity? No. It stops at -1, right? And when it's at -1, my f of x is at 1. It's always your vertex. Now for the next one, right here. As my x goes to positive infinity, what happens to my function? Is my function going up or down? Up. Very good. Up. So that's what it looks like. And then we're going to identify the increase and the decrease intervals, okay? So, increasing. My graph is increasing, always, right? Is it ever decreasing? Never decreasing. It's increasing, and when it's increasing, it's always increasing on its domain. -1 to positive infinity. So whatever one you have, either increase or decrease, is always going to be on your domain, but you never use square brackets. Now your transformation. Is this graph reflected at all? Is there any negatives indicated here? Reflected over either axis. What do you think? No. But it's shifted 1 unit. Is it left or right? Left. 1 unit left, and then 1 unit up or down? Yep. 1 unit left, 1 unit up. Very important to know this. So this is left, and then up is this one right here. White would not make sense. Up. That's where that comes from. You guys see that? Understand that? Makes sense so far? Okay. Let's try another example. So this is something new. We haven't seen this before. We have a negative sign outside of this. Anybody know what that means? What kind of reflection this is? I think I said it on the very first page of your notes. Anybody know what kind of reflection that is? Well, if it's not over the y-axis, it's probably over the the x-axis. So this is an x-axis reflection, okay? Is there any -1 I have to factor out inside the square root? Yes, I do have to factor it out. It's going to be f of x equals negative square root of -1x minus 2 plus 1. So I just factored out a -1 inside the square root. You guys all see that? So this one is reflected over the x-axis and the y-axis, isn't it? So what's my vertex going to be? You guys have to be able to identify this. Anybody know what my vertex is going to be? +2 is correct, but it's actually going to be a +2 here too. For the bell. Okay, so the reason that it's positive and positive is because before you identify the vertex, if you have a -x right here, you first need to factor out that -1, okay? Once I factor out that -1, I'm looking here to identify my vertex, okay? So it's always going to be the opposite of what this sign is right here, which is a +2. So you always have to factor out that negative sign before you do anything like that, okay? So that's the reason that it's a +1 instead of a -1. Does that make sense now? Okay. So now I'm going to find my root, and to find my root, I'm going to set f of x equal to 0. So replace f of x with 0, and you're just going to solve for x here. So I'm going to subtract over the 2 outside the square root. That's going to leave me with -2 equals -1, because that's a -1, square root of -x plus 1. Divide both sides by the -2, and we get 2 equals square root of -x plus 2. Now, how do I get rid of a square root in math? Square it. That gives me 4 is equal to -x plus 2, which means that x, if you finish solving it, is equal to -2. So you guys can finish it, if you want, but I just skipped that step. The answer here for my root is -2, 0. Now my vertex here, I'm going to plot. My vertex is at 2, 2. And my root is at -2, 0, like this. So this graph is going to look something like, well, I'll just show you. So this is negative, it's a 2 right here, and this is a plus 2, and this is a negative sign right here. So your graph's going to look like this. See that shape right here, the blue? So it's actually going to kind of bend down, kind of like a Nike symbol, but backwards. So it's like this. So that's what your graph's going to look like. You guys see that? So your quadratic is basically, if it were to continue, it'd be up here. Now that we have the graph, we can identify our domain and range much easier now. So my domain is going to be from negative infinity to positive 2, right? And my range is going to be from negative infinity to positive 2 as well, because these values are going down on both sides. So opens down and left is going to be negative, negative. It'll be going downward. So end behavior, as x goes to, well, on this side, negative infinity, my function also goes to negative infinity. And as my x value over here goes to 2, my f of x value goes to 2 as well. And then we're going to talk about increase and decrease intervals. So if I read from left to right, okay, my graph is actually never decreasing. It's always increasing. And it's increasing on its domain from negative infinity to positive 2. Alright, so now we're going to identify its transformation. So this is reflected over x and y axis. And this is shifted 2 units right and 2 units down. Alright, so for example 4, did you guys get to the point where I'm at right now? You guys understand everything that happened? I did make an error on my root real quick. Just a reminder, make sure you check your work. Okay, anybody can make an error. So now let's talk about our transformations. So we didn't have to factor anything out in front of the x, so we don't have a y reflection. However, we do have a negative in front, which means we have an reflection over the x-axis. Good. So the negative on the outside means that we have a reflection over the x-axis. And then this negative 1 means that we shifted 1 unit to the right, right? And then lastly, this positive 1 means we went 2 units up or down? Up. So that's how you do example 4.